Dimensional analysis, also known as the factor label method, is a method for solving chemistry and physics and science problems. It is a general technique, but it is very difficult to pass this class, or any chemistry class really, without being proficient at dimensional analysis. I would consider this a core concept which you need to master. It will serve you well on exam 1, and it will serve you very well later in the semester as well. So with that, let me show you how to work dimensional analysis problems. So let's teach by example with this one. For example, if you know that 2 loaves of bread cost $4.28, how much do 17 loaves cost? The first thing one does with dimensional analysis is set your answer up. And so the answer we're looking for is how much. Now recall, we are interested in the dimension, in the unit primarily. We're not going to worry about the numbers until the very end of this thing. It's opposite how you normally do. We normally throw numbers at it and then just slap the correct unit on it at the end, what is hopefully the correct unit. This is totally different. In this case, we work the unit or the dimension first, and then the number comes last. So with that, how much? I'm going to let a box represent the number I don't know, and a dollar sign represent the unit because I wanted to know how much. And the other thing I'm going to do is write this over 1 because I want to make sure that I can differentiate my numerator and my denominator. And you'll see why that's important in just a second. Now I need a place to start, and I'm going to start with 17 loaves because that's what the problem gives me, is 17 loaves. And so I'm going to use a star to represent that. A star is what I'm going to use to represent the place I start. So in the future, we've got a box. A box is what we're looking for, and a star is where we're starting. In this case, I'm starting with 17 loaves because that's what the problem gave me. Now, paying attention to the units, what do I need? If this is my answer, a dollar sign, and I'm now at loaves, what do I need to do? I need at least 1 conversion factor, and I'm going to show that with a train track. I'm going to just use this train track, and as many conversion factors as I need is as many rungs on my train track as I'm going to use. And in this case, I know I need at least 1 more rung on my track. Why? Because my unit as it now stands is loaves, but what am I looking for? Dollar signs. And I will not be done with this problem until the unit on the right side is exactly equal to the unit that I'm looking for. So how am I going to get there? Well, I need what's called a conversion factor. And I read to see if I can dig a conversion factor out of the way the problem's written, or do I have a conversion factor memorized? Do you have some memorized? Sure, you already have a bunch of them memorized. For example, you know in 1 kilometer, there's 1,000 meters. And so that's a conversion factor between kilometers and meters. But what can I do here? It's not asking me kilometers and meters. It's asking me for dollar sign and loaves. Well, it just so happened the problem gives me some more information. It tells me that 2 loaves cost $4.28. In other words, they're equivalent. 2 loaves is equivalent to $4.28. Or I could write it the other way. $4.28 will buy me what? 2 loaves of bread. Okay, which one of these conversion factors am I going to use? I'll use CF for the abbreviation of conversion factor. Why do I call these conversion factors? Because it has a unit in the top and a unit in the bottom. It has a unit in the numerator and a unit in the denominator. Anytime you have a ratio of numbers that relates to different units, you can refer to that as a conversion factor. In this case, I'm going to use conversion factor on the right. Why is that? Well, because if I use the one on the right, loaves, the unit of loaves will be in the denominator, and the unit of dollar signs will be in the numerator. And look what happens when we arrange it that way. Loaves cancel out, and the only unit left on the right-hand side of my equation is a dollar symbol. And guess what I'm looking for? A dollar symbol. This is what tells me I'm essentially done with my problem, except for multiplying and dividing out the numbers. So what does that look like? The way we do this is any digits that are in the numerator, you precede it with a multiply sign. And any digit that is in the denominator, you precede it with a divide by sign. So you will get the correct number if you take 17 and multiply it by 4.28 and then divide by 2. Or if you start with 17 and divide by 2 and then multiply by 4.28. Multiplication and division are commutative. It doesn't matter what order you do them in. Just so long as you remember, if the number is in the numerator, precede it with a multiply sign, and if it's in the denominator, precede it by a divide by sign. And so in this case, when I punch those numbers out, gives me the digits 36.38. What unit do I use? The only unit left standing, a dollar sign. Is that correct? Absolutely, because I was looking for some number with a dollar sign in front of it. And what did my answer come up with? Some number with a dollar sign in front of it. And so I know that is the correct answer. It's going to take $36.38 to buy my 17 loaves of bread.